Good morning, students. Hope all of you are safe at your home. So, in the last video, we have seen about exercise 1.3 and how we'll be dealing with the question of exercise 1.3. Hope all of you understood. Now, in this video, we'll be dealing with exercise 1.4. So, before going to the exercise 1.4, we'll be seeing three theorems related to this exercise 1.5, theorem number 1.5, 1.6 and 1.7. These two theorems, theorem 1.5 and 1.6 are vice versa to each other, whereas 1.7 it's a little bit different. Whether it is related to these two, but a little bit different. So what theorem 1.5 and 1.6 says? 1.5 says, if the decimal expansion of any number p upon q terminates, that means decimal expansion of p upon q is terminating, then q must be of the form of 2 raised to the power n and 5 raised to the power m. So let's take the example. So 1 upon 10 for sake. So what will be the decimal expansion of it? It will be 0.1. Here the denominator you can see it is 10. 10 means 2 into 5. That means 2 raised to the power 1 and 5 raised to the power 1. That means this q or this 10 is of the form of 2 into 5 or 2 raised to the power 1 and 5 raised to the power 1 form. Okay, so that is why we have got this as a terminating decimal expansion. Okay, another example of it we can take as 1 upon let's say 8. Okay, so 1 upon 8 means what? 1 upon 2 raised to the power 3. We can multiply it with 5 raised to the power 3. So what it will be? 5 raised to the power 3, 125, and this will be what? 2 into 5 raised to the power 3. What that means? 125 upon 10 raised to the power 3, that is 125 upon 1000, or you will be getting 0.125. It is a terminating decimal expansion. Okay, and the denominator has the form 2 raised to the power 3. So students, here whenever there is a terminating decimal expansion of any rational number, then the denominator will always be having a form of 2 raised to the power n and 5 raised to the power m. This you have studied also in the 9th class as well. Okay, that means terminating decimal expansion shows the denominator of the terminating decimal expansion shows factors of 2 and 5, either 2 or 5 or 2 and 5 both. Okay, this you have seen in the last year. So theorem 1.5 says, if a rational number is having terminating decimal expansion, then q must be having this. Okay, whether the theorem 1.6 says, if the denominator of a decimal expansion, the denominator of a decimal expansion or a number or a fractional number is of the form of 2 raised to the power n and 5 raised to the power m, then its decimal expansion will be terminating, means vice versa it is. Okay, now look at the theorem 1.7. Here the theorem 1.7 says, if in a fraction p upon q or in a rational number p upon q, q is not having the factor as 2 raised to the power n and 5 raised to the power m, then the decimal expansion of this rational number will be non-terminating repeating. Okay student, so these are the three theorems related to this exercise. Now let's come to the exercise 1.4, which is a quite easy exercise. Okay, and this is the last exercise of this chapter. So let's begin. So question number 1, it says, without actually performing the long division, state whether the following rational number will have a terminating decimal expansion or a non-terminating repeating decimal expansion. For that, what we will be doing? We will be converting them in the form, means the denominator of those number will be converting in the form of 2 raised to the power n and 5 raised to the power m, and we will be seeing if it comes, then they will be having a terminating decimal expansion. Okay, let's take the first one question. It says 13 upon 3125. So 3125 means it is 5 raised to the power 5. Okay, here 2 raised to the power is what? We can assume 2 raised to the power as 0, because there is no 2. 3125 can be written as 5 raised to the power 5. Okay, and 2 raised to the power 0 we can assume here, because the power 0 of any number gives value as 1. So since its denominator contains what? Its denominator contains a factor of 2 and 5, 2 raised to the power n and 5 raised to the power m. So the decimal expansion of this number will be what? Terminating. So we can write it here, terminating decimal expansion. Okay, so now question number second. It says 17 upon 8. So 17 upon 2 raised to the power 3 into, we can write 5 raised to the power 0. Why? 8 is 2 raised to the power 3, and here is not any 5 raised to the power, means no number of 5. So we can write as 5 raised to the power 0. So it is of the form of, the denominator is the form of 2 raised to the power n and 5 raised to the power m. 2 raised to the power n, 5 raised to the power m. So its decimal expansion will be what? Terminating. So terminating decimal expansion. Okay, next question is what? 64 upon 455. So here we can see that 64 upon 445, and the denominator is what? 445. We will be doing the prime factors of 445, and they will come as 5 into 7 into 13. Okay, so here we can see that we can write here the 2 raised to the power 0, and it will become 2 raised to the power n and 5 raised to the power m, that is 1. But here are two extra numbers, 7 and 13. So will it be terminating decimal expansion? Obviously not, because here are in the denominator two numbers are extra, which are prime, as well as they will not be divided by the numerator. So we will be writing here directly that it is a what? Non-terminating decimal expansion. Now here is the fourth question. 15 upon 1600. Here we can write the 1600 as 2 raised to the power 6 and 5 raised to the power 2. Okay, these are what? Its prime factors of the 1600. So the denominator of this fraction is of the form of 2 raised to the power n and 5 raised to the power m. So the decimal expansion of this will be terminating. Okay, now the next question, 29 upon 343. 343 is what? Is a cube of 7. So the denominator of this fraction can be written as 7 raised to the power 3, and here you can see there is no factor of 2 raised to the power n and 5 raised to the power m. So this fraction will non-terminating decimal expansion. Okay, now again the question number 6. 23 upon 2 raised to the power 3 and 5 raised to the power 2. So the decimal expansion of it, the prime factors of the denominator of this fraction are 2 raised to the power n and 5 raised to the power m. So terminating decimal expansion. Okay, so here n and m, that is in the denominator of the decimal expansion, the n and m can be any integer. Okay, so there is no restriction that n and m will have a certain value. They can be any integer. Okay, so that is why in every question you are getting 2 raised to the power uh, uh, 2 raised to the power n and 5 raised to the power m, different. Okay, so now the next one question, the question number 7th. So it says 129 upon 2 raised to the power 2, 5 raised to the power 7, and 7 raised to the power 5. So here 7 raised to the power 5 is here, 2 raised to the power n and 5 raised to the power m are here, but an another extra number is here, so it cannot be a terminating decimal expansion, and it will be what? Non-terminating decimal expansion. So now question number 8. Question number 8 is 6 upon 15. So we can simplify it by cutting it with 3. So 3 2s are 6 and 3 5s are 15. So it will be what? 2 upon 5. So here we can write it as 2 upon 2 raised to the power 0 into 5 raised to the power 1. Again, it contains, the denominator of this fraction contains 2 raised to the power n and 5 raised to the power m. So it will be what? Terminating decimal expansion. It will be terminating decimal expansion. Now question number 9th. 35 upon 50. So here is the question number 9. 35 upon 50. So this 50 we can express in the form of 2 into 5 raised to the power 2. So it is the form 2 raised to the power n, that is 1, and 2 raised to the power m, that is 2. So the decimal expansion of this fraction will be what? Terminating decimal expansion. Okay, so now the next question, 77 upon 210, we can divide it with 7. The numerator will go on with in 11 times, and the denominator 3 times, so 11 upon 30. So here this 30 can be expressed, or the prime factorization of this 30 will be what? 3 into 2 into 5. So here is 2 raised to the power n and 5 raised to the power m form, but another number 3 is here, so this will not be, means the fraction will not be a terminating decimal expansion, it will be a non-terminating decimal expansion. So this is the last question of this of the first question. Now the question number 2nd. Second question says, write down the decimal expansion of those rational number in question number 1 which have terminating decimal expansion. So all of we know that what are those terminating decimal expansion. The question number 1st, 2nd, 4th, 6th, 8th, 9th. Okay, so the first one now at the first. So it was what? 13 upon 3125. This was the terminating decimal expansion. So we have written in the form of 5 raised to the power 5. Okay, so we will multiply extra 2 raised to the power 5 in the numerator and in the denominator. Okay, so it will be what? 13 into 2 raised to the power 5 is what? 2 to the 4 to the 8 to the 16 to the 32. So 5 times it is what? 32. And this 2 into 5 is what? That we can write it as 2 into 5 raised to the power 5. So it will be what? The multiplication of these two. it will be 416. The multiplication of these two is 10 raised to the power 5. 2 5s are 10. So when we will be dividing it, what it will become? At first we will write it like this: 2 3 4 5, 5 zeros. So now the decimal expansion of it will be what? 0.00416. So this is the decimal expansion for the first one, the first part. Now the second part, 17 upon 8. So we have written it in the form of 2 raised to the power 3. So we will multiply extra 5 raised to the power 3 in the numerator and in the denominator. So it will become 17 into 125 upon 2 into 5 raised to the power 3. So the multiplication of these two is 2125 upon 10 raised to the power 3. 2125 upon 1000, and it will give you a decimal expansion 2.125. Now the question number 3, 15 upon 1600. So 15 into 5 raised to the power 4, and this will what? 2 raised to the power 6 and 5 raised to the power 2. So obviously extra 5 raised to the power 4 we have to multiply in the numerator and the denominator to specify this 6. Okay, so it will become what? 15 into 5 raised to the power 4 gives you 625. So here it will be 2 raised to the power 6 and 5 raised to the power 6, and the multiplication of these two will be 9375 upon 2 into 5 raised to the power 6. It will become 9375 and 10 raised to the power 6. So it is 9375 upon 1 2 3 4 5 6. So the decimal expansion of it will be what? 1 2 3 4 5 6. 0.00935. Similarly, other parts of this question are as follows. So here is the sixth one: 23 upon 2 raised to the power 3 and 5 raised to the power 2. So here 2 is still the power 3 and 5 is still the power 2. So we have to increase one power of 5. So we will multiply with a 5, okay, in the numerator as well as in the denominator. The 23 into 5 will become 115, and this power will increase of 5 because of this 5. So it will become 2 raised to the power 3 and 5 raised to the power 3. Now it will become 115 upon 2 into 5, that is 10 raised to the power 3, that is 115 upon 1000, that is 0.115. Now question number 8, 6 upon 15. 6 upon 15, it will cut with a 3. 3 2s are 6 and 3 5s are 15. So 2 upon 5 it will become. So here is no 2 in the denominator. So we have to make a pair of 2 and 5. So we will multiply with the 2. So 2 in the numerator, and as well as for the pacification it will be multiplied in the numerator as well. So 2 2s are 4 and 2 5s are 10. So 4 upon 10. So it will become 0.4. Now the question number 9, 35 upon 50. So this 50 we have expressed already in the previous question. 35 upon the 50 we have written as 2 into 5 raised to the power 2. So here also we can write it as 2 into 5 raised to the power 2, and here we'll have to multiply it with the extra 2, the denominator. So extra 2 will be multiplied in the numerator as well as in the denominator. So it will become 35 into 2, that is 70, and 2 raised to the power 2 and 5 raised to the power 2, that is 10 raised to the power 2 it will become. So it will be what? 70 upon 100. Okay, so 0.70. So this is the end of the second question. The third one question of the book says, it says the following real number have decimal expansion as given below. In each case, decide whether they are rational or not. If they are rational and of the form of P upon Q, what can you say about the prime factors of Q? Okay, so the question is very much theoretical, not a numerical one question it is. It is less important as the point of view of the examination. So here we can see this that the decimal expansion of this number is what? It is terminating decimal expansion. So it will be what? A rational number, obviously. Okay. So the prime factors of Q in this case will be what? Of the order of 2 raised to the power n and 5 raised to the power of m. Okay. In the second case, here we can see that the decimal expansion of it is 0.120 4 times 0 dot dot dot, that is non-terminating. Dot 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 shows us what? It is non-terminating, and the random number shows us that is not recurring as well. Okay, so it is not terminating and not recurring. Okay, so it is a irrational number. Now so it cannot be expressed in the form of P upon Q. So there will be no need to say anything about the number, the prime factors of Q. So now the third one part, 43.123456789 bar, that is 123456789 will come again and again. So it is non-terminating but repeating decimal expansion. So this is a rational number. Okay, but the factor of Q will not be of the order of 2 raised to the power of n and 5 raised to the power of m. So this is rational, okay, but it is irrational. It cannot be expressed in the form of P upon Q. Now prime factors of Q, in this case prime factors of Q will be of the order of 2 raised to the power n and 5 raised to the power m. In the third one part, they will not be of the order of 2 raised to the power n and 5 raised to the power m. And here in this part, since we cannot express it in the form of P upon Q, so need not to say anything about the prime factors of Q. Okay, so this is the end of the first chapter. So stay tuned for the second chapter. Thank you.